Today we're going to be studying mathematics.
And emerges from the second mirror.
These words sound
Be your teacher for today.
Hello everyone, you're welcome to today's home lesson. Today we're going to be looking at the topic lowest common multiple, LCM, and highest common factor, HCF. Lowest common multiple, LCM. Now we are looking at some numbers and we are looking at the lowest number that is common to them. A group of numbers, what is the lowest number, lowest multiple that will be common to them? Let's take for example we want to find the lowest common multiple of 12, 42, and 14. We could use any of two methods. In the first method, we look for the multiples of each of these numbers. We look for the multiples of 12, multiples of 42, and multiples of 14. Okay, multiples of 12. Multiples of 12. The first multiple of 12 here is 12 times 2, 24, times 2, 36. Next will be 48, 60, 72, 84, 96. We could go on. Let's look at the multiples of 42. Multiples of 42. The first multiple of 42, 42, 84. 84 plus 42 will give us the next multiple. So we have 126. The next multiple of 42 will be 42 plus 126. That will give us 2 plus 6, 8, 4 plus 2, 6. Now, multiples of 14. The first multiple of 14, 14. The next multiple will be 14 plus 14, which will be 28. The next multiple of 14 will be 28 plus 14. 4 plus 8 is 12. We have 2 here. Then 1 plus 2 is 3 plus 1, 4. Now 14 times 4. 14 times 4. 56. The next multiple of 14 will be 14 times 5. 20. 70. The next multiple of 14 will be 14 times 6. 24. The next multiple of 14 will be 14 times 7. 7 times 1, 7 plus 2, 98. Now, to get the lowest common multiple, the lowest number, the lowest multiple that is common to 12, 40, 14, and 42. When we look through these numbers, we can find 84 here, 84, and 84. So I come here, the LCM of 12, 42, and 14 will be 84. The lowest common multiple of 12, 42, and 14 will be 84. Another method Method 2. To find the LCM of 12, 42, and 14. 12, 42, and 14. I'll look for the numbers that could be used to divide each of them in steps. I can use 2 here. 2, how many 2 can I find in 12? I have 6. How many 2 can I find in 42? 21. How many 2 can I find in 14? 7. What else could divide this in steps? 2. How many 2 can I find in 6? 3. How many 2 can I find in 21? None. So I'll write that 21 back. How many 2 can I find in 7? None. So I'll write the 7 back. What can I use to divide those numbers again? Let's try 3. How many 3 can I find in 3? 1. How many 3 can I find in 21? 7. How many 3 can I find in 7? None. So I'll write back my 7. What can I use to divide? I have 1, 7, and 7. Sure, 7 should go. I have my 1 back here. How many 7 can I find in 7? 1. How many 7 can I find in 7? 1. So the LCM of 12, 42, and 14 from what I've done here would be 2 times 2 times 3 times 7. 2 times 2 is 4. 4 times 3 is 12. Now 12 times 7. 12 times 7. 7 times 2 is 14. Lift 1. 7 times 1 is 7 plus 1, 8. I have 84 here. So I'll come to say the LCM of 12, 42, and 14 is 84. You can see from the first method and the second method, I have the same answer. LCM of 12, 42, and 14 is 84. Either of the method could be used, but I think you would find this easier. So we'll use this for our next example. We want to find the LCM of 48, 40, and 12. LCM of 48, 40, and 12. Let's use the second method, the LCM of 48, 40, and 12. What number could divide these numbers? Let's use 2. How many 2 can we find in 48? We have 24 here. How many 2 can we find in 40? We have 20. How many 2 can we find in 12? We have 6. What number could we use to divide again? Let's try 2. How many 2 can we find in 24? 12. How many 2 can we find in 20? 10. How many 2 can we find in 6? 3. What number could we use to divide again? 2 could still go. How many 2 can we find in 12? 6. How many 2 can we find in 10? 5. How many 2 can we find in 3? None. So we put down this 3 again. Now what number could we use to divide? 2 could still go. 2. How many 2 can we find in 6? 3. How many 2 can you find in 5? None. We put down the 5 again. How many 2 can we find in 3? None. We put down the 3 again. What number could we use to divide this? Let's try 3. 3 would give us 1. How many 3 can we find in 5? None. We put down the 5 again. How many 3 can we find in 3? 1. What number could we use to divide? We only have 1, 5, 1. So we use 5. How many 5 here? None. 1. 5 here? 1. 1. So the LCM of 48, 40 and 12 would be 2 times 2 times 2 times 2 times 3 times 5. The LCM of 48, 40 and 12 would be 2 times 2 times 2 times 2 times 3 times 5. 2 times 2 is 4, times 2, 8, times 2, 16. Now we have 16 times 3 times 5. 16 times 3, 3 times 6, 18, lift 1, 3 times 1, 3, plus 1, 4. So we have 48. That is 48 times 5. So 48 times 5. 5 times 8 is 40. Write 0 and lift 4. 5 times 4 is 20. Plus 4 would give us 24. So we have 240. So this gives us 240. That means the LCM of 48, 40 and 12 would be 240. The LCM of 48, 40 and 12 will be 240. Now we're going to go into HCF, highest common factor. Highest common factor. What we've just treated is lowest common multiple, but now we are going to highest common factor, HCF. Highest common factor. Now we are looking at the highest number, highest factor that is common to a set of numbers. The highest number that is common, the highest factor that will be common to a set of number. We want to look for the HCF, highest common factor of 21, 63, 91 and 105. What is the highest factor? Highest factor that could be common to them. Now we break each number down. Would go this way. For 21, what are the factors of 21? Factors of 21. Factors of 21. What number could divide 21? We have 3. How many 3 can we find in 21? 7. What number could go? 7. 7, 1. So the factors of 21 is 3 and 7. Let's look for the factors of 63. 63. What number could divide 63? Let's try 3. How many 3 can we find in 63? 3 in 6 we have 2 and 1. Then what number could divide again? 3. How many 3 can we find in 21? 7. How many, what can we use to divide 7 again? 7. So the factors of 63 is 3, 3 and 7. What are the factors of 91? What numbers could we use to divide 91? Let's try 7. 7. How many 7 can we find in 9? 1. Remainder 2, making 21. How many 7 can we find in 21? We have 3. What number could divide 13 again? 13 is a prime number, so only 13 could divide 13 again. So we have 1 here. So the factors of 91 are 7 and 13. Let's look for the factors of 105. 105. What numbers could divide 105? Let's try 3. How many 3 can we find in 10? We have 3, remainder 1. 3 times 3, 9. 10 minus 9, 1. How many 3 can we find in 15? 5. What number could we use to divide this again? We have 35. Let's try 5. How many 5 can we find in 35? 7. 7 is a prime number. So what would we use to divide 7 other than 7? 7 would give us 1. So we now come this way. Factors of 21. Factors of 63. Factors of 91, factors of 105. The factors of 21 here are 3 times 7. 3 and 7. Factors of 63. 3 times 3 times 7, which could also be 9 times 7. Factors of 91, we have 7 times 13. Factors of 105, we have 3 times 5 times 7. Now, remember we are looking for highest common factor. Highest common factor. Highest common factor. The highest factor that is common to 21, 63, 91, and 105. Looking at these numbers, which of the factors is common? We can see 3, 3. Oh, there's no 3 here, so we can't use 3, although there's a 3 here. We have 7 here, 7, 7, 7. So we could take this 7, 7, 7, 7. Is there any other factor common to all of them? No. So the only factor, the highest common factor of 21, 63, 91, and 105 would be 7. Do you understand that? We'll take another example. Let's find the highest common factor of 16, 32, and 40. 16, 32, and 40. Using the same method, we want to look at what are the factors of 16, what are the factors of 32, what are the factors of 40. Factors of 16, what number could divide? You could use bigger numbers, but it's better to use the smaller numbers first so that you don't make a mistake. 2 would give us 8, another 2 would give us 4, another 2 will give us 2, and 2 and 2 would give us 1. You keep breaking down until you arrive at 1. Now, what are the factors of 32? What are the factors of 32? What numbers would divide 32? 2. How many 2 can we find in 32? Here 1. In 12, 6. What number could divide 16 again? 2. 2. How many 2 can we find in 16? 8. What can we use again? 2. How many 2 can we find in 8? 4. What number could divide 4? 2. How many 2 can we find in 4? 2. What number can divide 2? 2. How many 2 can we find in 2? 1. Let's go for the factors of 40. What are the numbers that could divide 40? Let's try 2. How many 2 can we find in 40? We have 20. How many 2 can we find in 20? We have 10. How many 2 can we find in 10? 5. What number could be used to divide 5? 5 is a prime number, so only 5 can divide 5. 1. Now, we come out to write the factors. Factors of 16, factors of 32, and factors of 40. From what we have on the board, factors of 16, 2 times 2 times 2 times 2. Now, factors of 32. From what we have on the board, 2 times 2 times 2 times 2 times 2. Now, factors of 40. We have 2 times 2 times 2 times 5. Now, what is the highest common factor? What is the highest factor that is common to 16, 32, and 40? We have 2, 2, 2. A set of 2. 2, 2, 2. Another set of 2, 2, 2, 2. Another set of 2. We have 2, 2. Oh, there's no 2 here, so we can't use that. We have 5 here, but there's no 5 here and there's no 5 here, so it's not common. So the factors, the highest common factors of 16, 32 and 40 would be 2 times 2 times 2. It implies that the highest factor that could divide 16, 32 and 40 is 2 times 2, 4 times 2, 8. So the highest factor that could divide 16, 32 and 40 is 8. I hope you got that. So this brings us to the end of this class. I hope you enjoyed the lesson. Meet you in the next lesson. Thank you.